Welcome to this video explaining the differences between BIOS and UEFI. We'll explore how your PC actually boots up and how these two firmware standards manage the process. Have you ever wondered what happens in the background between pressing the power button and seeing your desktop? The answer lies in the firmware. Before your operating system loads, a small program, called firmware, runs first. This firmware, either BIOS or UEFI, is stored on a small chip on your motherboard. It wakes up your hardware and hands control over to the OS. BIOS, or Basic Input/Output System, is the original firmware, dating back to the 1980s. It is the very first code a computer runs. It's considered legacy firmware, being over 40 years old. The classic BIOS boot sequence has 4 steps. First, it powers on and wakes up. Second, it runs a power on self-test, or POS, to check the hardware. Third, it reads the master boot record from the disk. Finally, it loads the bootloader to start the operating system. BIOS operates in 16-bit real mode. This has several drawbacks, including a memory limitation of only 1 megabyte. It cannot use modern CPU features and is slower due to single-threaded execution. Another problem with BIOS is the disk size limitation. The master boot record, MBR, uses a 32-bit field for disk size, which limits it to a maximum of 2.2 terabytes. Anything beyond that is invisible, and it is also limited to just 4 primary partitions. BIOS is also associated with slow boot times due to sluggish post-checks. Its interface is text-only and keyboard-only, lacking modern features like mouse support or built-in security. Now let's look at the modern replacement, UEFI. This is the second section of this video. UEFI stands for Unified Extensible Firmware Interface. It's the modern firmware standard, mainstream since 2012. It's essentially a small operating system that runs before your main OS, offering mouse, graphics, and network support. The UEFI boot process is file system aware. It powers on and loads, reads the GPT partition table, and finds the EFI system partition, which is a FAT32 partition. Finally, it runs an actual EFI bootloader file, making the process more flexible than BIOS. One major advantage of UEFI is that it runs in full 32-bit or 64-bit mode. This unlocks all of your CPU's 64-bit features during boot, allowing for more memory, modern instructions, and parallel tasks. UEFI uses GPT partitions, which support disks up to 9.4 zettabytes. This is effectively unlimited for any real-world disk. GPT also allows for up to 128 primary partitions, far surpassing the limitations of BIOS's MBR scheme. Secure Boot is a key advantage of UEFI. When a bootloader tries to run, UEFI checks its signature. If the bootloader is signed, it runs. If unsigned, it's blocked, providing protection against rootkits and boot time malware. Finally, UEFI offers significantly faster boot times, often by seconds. This is because it parallelizes hardware initialization and skips the legacy post-checks that BIOS performs every boot. UEFI's graphical setup interface is another advantage. It supports a mouse, modern menus, and can display real-time sensor data, unlike the text-only blue screen interface of BIOS. This brings us to the final section of the video, a head-to-head comparison between BIOS and UEFI. Looking at the scorecard, UEFI, since 2012, supports 32/64-bit CPUs, large 9.4 zettabytes disks with 128 primary partitions, faster 10-second boots, a graphical interface, secure boot, and built-in network boot. BIOS is limited in nearly every area. The partition scheme difference is significant. BIOS uses MBR, limited to 4 primary partitions and 2 terabytes disk size. UEFI uses GPT, which offers 128 primary partitions and support for disks up to 9.4 zettabytes. In terms of security, if a malicious bootloader tries to run, BIOS executes it without question. UEFI performs a signature check, and if the bootloader is unsigned, it is blocked, keeping the OS safe. To check which firmware you are running on Windows, press Win+R, type MSInfo32, and look for BIOS mode. On Linux, check for the existence of the /sys/firmware/EFI directory. UEFI matters because it is faster, booting in about 10 seconds. It is safer, thanks to Secure Boot and TPM integration. It also handles bigger disks with fewer partition limits. You may still see BIOS or legacy mode in old PCs, industrial equipment like POS terminals, and computers running legacy operating systems. Some UEFI boards use CSM mode to emulate BIOS for compatibility. Think of BIOS as an old brass key, simple, functional, but easily copied. UEFI is like a smart keycard, encrypted, logged, programmable, and easily revoked if compromised. The main takeaway is that BIOS and UEFI perform the same job, booting your hardware. UEFI, however, does it faster, safer, and with far fewer limits. If your PC was made after 2012, you are almost certainly running UEFI. Thank you for watching this video. If you liked this content, please consider subscribing. We'll be doing a deep dive into MBR versus GPT next.